Put your feet next to the action. Right, let's get started. Welcome everybody to the inaugural London Facebook React user group. I looked for one, I couldn't find one, so like, if there isn't one, what do? You have to create one, mate. Same as software. Red Badger doesn't own this group. It's nothing to do with Red Badger really. It's just a forum for us to learn about Facebook React. I've absolutely no idea how much exposure to Facebook React or how many people are using it in production or in development or building projects with it right now. But I'd like to know. It'd be actually quite interesting actually for everybody to know. Who's using Facebook React? Cool, okay. Who's got an app in production? Hooray. 2 weeks time, yeah, that counts. Brilliant, brilliant. So, my battery's going to keep, I should probably stop that doing that. So anyway, welcome to Red Badger offices. If there's a fire, there's an exit up there where you came in. There's also a fire exit just in that corner, and you can get out the back. But there's no exit to street level that way. Mix of homes, beer, pizza, toilets that way. The agenda, which we've put together. So this is like the first attempt at this, right? So we're not quite sure exactly. It will get better as more and more people from within the group start contributing and start, like doing talks of their own. But we're going to start with a talk from Alex. Alex there, he's a Badger. He's going to talk about using LiveScript with React because we've been using it for quite a while. We've done about three or four projects now, and the JSX stuff doesn't quite work with this, so we kind of, and we're LiveScript fans anyway, so you'll see it, and it looks great. I don't know whether it's a good thing or not, but it might be. I'm going to talk a little bit about isomorphic apps, because that's like a kind of holy grail in web app development, and React makes it quite easy. So I don't know if any of you are doing that at the moment, but it's really, really cool. Fortunes is going to talk a little bit about React Jade. Cool. And then we'll have beers and stuff, and you can stay as long as you want and have beers and chat and stuff afterwards. So, should we start?
Yeah.
Good stuff. Do you want your chopping up your?
Yeah.
Or have you got it there?
Yeah.
Do you want me to? You can do it on here. I've got it also.
Oh, really? Okay.
Yeah.
Yeah.
First things first.
Hello, my name is Alex Savian. I work on production, and we're talking about React.ls. React.ls is our attempt to mix React.js and LiveScript. And LiveScript is this language that Steve just mentioned we've been used for these 3 projects. So let's see how it goes. This talk is not actually supposed to be 20 minutes, more like 5 minutes, but we can switch to Google I/O. We get some time. Right. So when you start learning Facebook React, the first thing you stumble on is JSX, and if you listen for Facebook guys presenting the whole thing, they usually mention that JSX is this thing. Why they actually wanted to do it is because Facebook designers understand CSS and HTML, but apparently don't understand JavaScript. So they they came up with this brilliant thing called JSX. So it looks like this, and it's like JavaScript and HTML, everything mixed at the same time. So assuming that when a Facebook designer sees this, he automatically managed to see the HTML and start cracking. So JSX can be, well, when you start doing those larger components, it can be obviously bigger, and luckily there is, and JSX, as you know, it compiles then back to JavaScript, and then you can run this normal thing. So in just plain JavaScript, it will be like this. So they have all the methods and all the functions to actually create those DOM elements. But if you go even a step further, I just used the LiveScript, it will look like this. Ta-da. Right, so meets the LiveScript. LiveScript is a pretty interesting language. It's really functional as opposed to, well, it has all the benefits of JavaScript, and then it has also the benefits of functional languages like C and Haskell and Lisp. Well, maybe not all of them, but very good. So it gets very nice scoping, handles scopes very well. It has it can convert dashes to command cases, and has pipe operator, so you can pipe your data through the pipes and then end up with data you actually want. Correct functions, constants. It also has a very nice standard library called Prelude.ls for even more goodness. And in React.ls, the component render will basically look like this. So, as you know, indentation is really important with LiveScript, so it basically creates blocks, and this is called a function, and then passing parameters. And then this is another parameter, and then this is another parameter. Then it has also do blocks, so you can also do create objects in the do block. You can have ifs and styles and all the goodness of the functional language. So as you know, React component constructor functions have same two arguments, initial props and children. So this is why you pass, when you call constructor, you basically just pass initial props and you also pass children. The best thing about the children, it can be also an array of children, and then you can nest all those children inside, and then you get this whole thing. So again, JSX, which can be like this. Now we have a little bit of data processing and some stuff. And in LiveScript, it would look like this. And now we are looking. Now we're using even more functionality of LiveScript and AWS. So there is a mock function where we pass mark the array, and then the mock function basically it takes the function as an argument, and then it is basically will be one single member of this array, and then it just goes through every single member of the array and then it creates all the elements. And this is again like a custom React component, and we are passing some of the arguments from the it, which comes from the products. And yeah, so it's very neat. Nice. You can see there's plenty of nulls. Nulls are needed because like you really have to provide something. So you get a null when you don't have any additional properties for the object, but you still have children. And yeah, so it looks almost like Jade, isn't it? But it's not exactly Jade. So if you do this kind of construction, so it's very in Jade it's very easy. Like you have blocks of markup, and sometimes you want to display some blocks, and you don't want to display another block, and you put an if, and then you have a block inside it. So if you try to do something like this, it will render only the last div hello there, because if obviously only returns the very last statement. So this whole block will not be displayed at all. So what you should do if you're actually using ifs in React.ls, you should wrap everything in one element, and then it will render everything beautifully. Yeah, so React.ls is a very interesting combination because you only have for one language, it's LiveScript. Everything is LiveScript, and it's not only a proper language, it's a functional language, but well, like the benefit of it is it's fully fledged functional language, so you can do data processing inside it, and you can do like arrays and current methods and piped goodness and all stuff. So you don't have to switch array context, you just write everything in LiveScript and that's it. Prelude.ls is a standard library which comes with LiveScript and functional approach, which kind of comes to this idea, should the designer know how to code functionally? Maybe, at least if he works in Facebook. Cons. No HTML, no Jade, just LiveScript. You can still have HTML, you can still have Jade, but you can also end up with an application which doesn't have any of those. It's just pure LiveScript, right? Some links. Ta-da. Good.
Cheers, Alex. So I'm making no apology for this, but the examples that I'm going to use in my bit are going to be all in LiveScript. So sorry about that. Is everybody using JSX and JavaScript, or is anybody using something different? What are you using? What are you using? Oh, you're using JavaScript.
I'm using JavaScript.
Okay, right, yeah. Is anyone using anything different?
TypeScript. That's what I use for that.
Okay, and what does that look like? Is that good?
It's JavaScript plus type annotations.
So it's messier or tidier or?
It's a lot better once you go over a few hundred lines. In the sense, like,
Okay.
the syntax is very similar, but if you ever change something, you get told when you
Right, sure. Yeah.
which is
Useful.
But in terms of how aesthetically it looks, the only downside is because the problem with JSX is you've got one language inside another, so the JSX compiler assumes it's processing a JavaScript file. So I'm just using effectively the JavaScript notation. But fortunately, since I don't have to worry, I don't have designers who are with Facebook problems, they have designers who want the familiar syntax. In this case, the designer, the better of all this is me. So.
Does anyone have any designers that do go into the code and do that? directly, or
Yeah.
do you?
Sometimes.
Yeah.
Yeah.
And do they find that JSX is a useful abstraction? Or do they? I mean, do they feel like they're at home, or does it make no difference?
They're just as bad as HTML. I do know one UX designer who works. One of the reasons he doesn't like Angular is because he doesn't really feel he can actually express himself through the code. It's a little too removed from HTML and CSS. And so far, he likes the look of JSX, but he hasn't used it. So.
I'm really interested in seeing whether it actually does have the benefit that it's perceived to have.
Oh, I think it does. I like seeing HTML rather than React.dom.tr or whatever.
Yes, yeah, of course. Yeah.
And I think
in JavaScript itself it looks messy. Yeah, I mean it doesn't.
if you use Sublime and you use a proper DTD that lets you see it as HTML and treats it like HTML, then it works fine. That's what we do.
I was experimenting with something where I was going to have the template or the HTML part actually as a separate require,
Right.
and then it would automatically load that in as being renders, but it didn't quite work. Didn't get that.
Interesting. Has anyone played with ON and ClojureScript?
No.
Does anybody want to?
Yeah.
There's quite a few people using it.
Yeah.
We've got closure people who are actually working full time with closure.
Mm.
And that's now the kind of like recognised closure stack for web development.
Because people, I think, from what I've been reading, people that are using it swear by it. I think it's absolutely like the future. I mean, the way to write.
Yeah, I met Nat Price last night. He said in 1 hour he downloaded React and wrote and implemented a user interface undo, multi-stage undo
Yeah.
in ClojureScript.
Yeah, because really it's actually quite straightforward when as soon as you get immutable state, and each state transition in your application is effectively a copy of the previous one. And you can store the whole state, and it stores any of the diffs anyway, so it's quite efficient. But then an undo is really effectively just reverting back to a different state and then re-rendering, and job's done. I don't know. I'm fascinated by functional approach to programming anyway, and you know, mutable state does cause all sorts of issues in applications. So if you had immutability and functional, then
Sorry, can I just ask, is LiveScript, does it support immutable state? Is it in that respect of your functional language?
No, it doesn't, and I think it would struggle to, because it's difficult to enforce that, isn't it? When you compile to JavaScript anyway, I suppose it could.
There is someone who has like they think they called it Roy. This guy's name was Roy.
Oh yeah.
But yeah, it's
Yeah. Now, I noticed that there is a React add-on called Update. I think it's in the add-ons, and it's like React add-ons.update, and you can pass it an object that describes which parts of an object graph you want to actually update, and it returns you a copy of the original object graph with those bits mutated, and then you pass that back to the render, and then that seems to be quite good, because like as soon as you can make some guarantees that the object graph you're going to put through the render is immutable effectively, or isn't it, then React can make all sorts of optimizations under the covers that make that, and that's what ON does. So ON performs better than React just because it knows that state, it's not going to change, and so it doesn't have to worry about all sorts of.
And that's part of just normal React. It's just part of the library.
Yeah. So and also, in the should render or something? Should component?
Should component update.
In there, if you've got immutable state coming in, it's actually really easy to reason about whether or not you need to go further.
We tried that a little bit. Well, I tried it a little bit with doing like a DB course on the object to see if it should update, but
Yeah.
the performance you lose by doing a DB course is the same as re-rendering without any DOM changes. So.
Exactly, but if you know that the state is immutable, you can do a reference course. So, and that's a lot cheaper. So I think you can just say like, you can use the triple equals in JavaScript to say, is this exactly the same instance? Because if it is, then I know it hasn't changed, and I don't need to go deeper. So I don't know. I think there's some benefits to, and I think React does that internally as well. So I think that there are some like massive performance benefits from guaranteeing that.
The ClojureScript libraries are really, the immutable collections are really just they got to be JavaScript.
Yeah, I guess so. Yeah,
it's written in JavaScript.
Yeah.
So the implementations of the immutable collections exist in that Clojure code base. Kind of like at the box.
If anybody wants to, I mean, obviously it goes for anything. But we're going to need people to do talks and all that sort of stuff. But on and ClojureScript, I mean, that's right high up on my agenda, and I know it's quite a few people have. But anyway, so I go back to what I was saying before. Is make no apologies. Everything in my talk is going to be live script, but so isomorphic applications. Then why? Okay, so JavaScript's now grown up, hasn't it? I mean, like we've got ES6 and stuff. We had CoffeeScript, LiveScript, we've got TypeScript now, we've got ClojureScript, we've got like all these different things, and it runs possibly on every device and on the servers, as well as in the browsers, and it's really, really fast. The latest engines are like massively fast. I don't know if it's worth looking at this, but that this is Firefox Iron, which is like steaming ahead of Chrome actually in some respects, and the optimizations that they're sort of like whacking out now are just unreal. And with Node becoming really, really popular, it makes kind of sense to write your application once and run it on client and server instead of twice, once for client, once for server. So that's kind of a bit. And then we also, I mean, we're doing a big project at the moment which has to work in non-JavaScript environments, and that's quite tricky. And it also has to be searchable and good for SEO and all that sort of stuff. Support deep linking, so you can just like jump into the app wherever you want. And when you load a page, it's load straight away. You don't want to delay while your app boots up in the browser. And we didn't want to write our app twice. And
when you say non-JavaScript environments, do you mean just somewhere where JavaScript is like there's a browser with JavaScript disabled, or do you mean something totally different?
So that would be one example. Yeah. I know that Google has started running JavaScript now when they index pages, but I don't know how successful it is. I think that for SEO purposes, a search engine should be able to index your page without JavaScript. Get something meaningful back. And there are also like screen readers and type things like that don't support JavaScript, and also we should be writing apps that conform to the standards of the web and are well laid out as far as the content that they provide. And if it's a RESTful web application and the web is RESTful by nature, then the server should be delivering pages or resources that make sense in non-JavaScript environments, even though JavaScript runs on every single machine on the planet. And I think there's only like half of 1% or something of all like traffic comes from a JavaScript disabled environment. And that, from what I can read, I can't really tell what they are. I don't think anybody really knows who these clients are. I don't think that they're humans that have turned JavaScript off.
So essentially, you mean client versus server side.
Second, sorry.
Do you mean basically client versus server-side rendering?
Yeah, I mean, I just think that you should be, the server should be able to render every single page in your app. There's lots of opinion in what I'm about to say, but I'm not really a big fan of single page applications, and I think that one big single page application that only runs client side, talks to an API, breaks the web in all sorts of different ways. And it might give you a great user experience for a human being, but it kind of breaks a whole lot of other things in the process, like all sorts of things like search engine optimization and caching, and being able to deep link and jump into the middle of an app and all that sort of stuff, and startup times and performance and back buttons and scroll positions, and it breaks a lot of things. So I'm kind of not really a fan of single page applications if that's all it is, but React brings something else to the table. So
with your stuff of the 1% that don't have JavaScript enabled,
yeah.
Well, there was that thing a while back which every client before the JavaScript loads effectively doesn't have JavaScript enabled. So you're also catering for before JavaScript loads. So say you had a slow 3G connection, you get the HTML loading, but JavaScript and whatnot doesn't.
Yeah.
So that's that as well.
Yeah.
HTML will get rendered if JavaScript is still. As opposed to the local JavaScript is not.
Which event often is, and which ideally it should be. So, because the goal shouldn't really be to prevent it from loading without JavaScript, because that's slow. Like it needs something like all the JavaScript gets.
I guess the problem would be you can't normally with a native app, you know when it's finished loading and it's ready. There's something written up and you wouldn't know when it's ready.
How do I do this? Sorry about that, it's just a bit going to speak. Yeah, so there's all sorts of problems associated with a single page application. And we had this problem on the project we've been working on, where we had to provide a user experience that worked in non-JavaScript environments. It was a condition that was set out from the beginning, it didn't have to have like 100% fidelity, but it did have to work. And so we found ourselves like in a position where we wanted to do clever things with JavaScript enabled, and we had to then repeat all that stuff on the server. So everything we wanted, everything on the client had to be on the server again. And so this like holy grail of web application development was presented to us. Ignore what's on the side now. Presented to us like a year and a half ago by a client who said, "I want to do this," and there was no one doing it at the time. And then Airbnb came out with Render, and then which is like backbone and handlebars on the server and the client, and we thought at the time, yeah, that's great. Let's do it that way. And there's been lots of platforms that have attempted to do that since. But have I gone too many pages forward? Sorry about this. Yeah, I have.
So, in terms of revolting, would you hold all those multiple pages on the site?
Yeah. Well, I'll come on to that in a second, because that's where I'm going with this. But there's lots of frameworks that have come since Airbnb Render, which profess to be somewhat isomorphic, but they're sometimes quite opinionated and often take over your whole stack, or dictate what that stack should be, and they're great, but if it doesn't give you the flexibility to mix and match and use the bits that you want to use, build your app in the way you want to build it, then it's a bit restrictive. And a lot of them do take over the whole thing. They're almost all MVC, which is like universal on the client and the server. And there's nothing wrong with it. It's just that we're React fanboys and girls, so we So we know, that there's possibly different ways of building apps and using, and also they're quite complex. And React is quite simple. So I thought what we'd try and do is work out how to build an isomorphic app that was in the simplest way possible. So I've got a demo in a bit about what I think that something might be, or an example of what that might be like. So one big single page application is problematic in a way, because you want that first page to load instantly, and it has to kind of have all the data it needs in order to render. So obviously React has server-side rendering as well as client-side rendering now. So if a page renders on the server, it's going to render again on the client. It has to have access to all of the data it needs. And so if you've got one big single page application, it can be quite difficult to work out exactly what data that page needs on the client and all that sort of stuff. And what we've been finding in the project that we're working on at the moment is that it's actually a little bit easier maybe to think of your app in terms of lots of little single page applications. So, or to think of them more as traditional pages that are rendered by the server, where you carry on client side for a little bit, and then so some of the links on your page are client side routed, and some of them are server side routed, and it actually doesn't really matter whether a link is server side or client side routed. If you've got JavaScript off, it's going to be server side routed anyway. If you've got JavaScript on, then you can do some clever things and let the URL hold the state with a client side router, and not necessarily make the whole application one big single page application, but instead think of it like an area of your app or part of your app that has some domain specific commonality or whatever that that makes it sensible for it to be its own little single page application. Obviously the user doesn't know any different, doesn't know whether your app is one single page application or hundreds of them. So I thought we'll throw together something that represents what we're doing in one of our projects, which one second. Let's get rid of that. So I don't know if that's big enough. It's not, is it really? Should have. Does anyone know how to make this bigger? Sorry? That'll do, won't it? Okay, so so this is a public repo, so you can go and have a look at it or contribute to it or whatever. But I wanted to put together a really simple isomorphic app that doesn't intrude on the way you would normally build an app too much. So this is a regular Express app in Node, written in LiveScript, obviously, but it basically just mounts these routes, and it's got a Jade view engine. But the Jade view, actually, there's only one view, and it's layout.jade, and it doesn't do anything. It hasn't got anything in it at all, apart from the HTML head and body. And when I was playing with this originally, I was thinking, well, I could get React to do that too. It's got HTML elements, it's got head elements, it's got body elements. It could do all of that, and I did try it, and it did work. But I don't know if you've done server-side rendering, and we'll look at it in a second. But if the server and the client don't render exactly the same thing, React comes up with this big message that says the server hasn't done the same thing as the client, and maybe it got something wrong. And I couldn't work out why it thought that the client was different or the server was different. But we'll talk about how they work in a second. But in the end, I thought it was easier to just have a single Jade view with a mount point in here, and the mount point we can mount any component we want in there, and that's all there is. So that's the only jade there is. And as far as the routes are concerned, there's only in this app there's only one route. So I've got effectively two apps, App 0 and App 1, rather imaginatively named. And this is just an express router, and it's got one route that mounts at the route, and it's just got an app and a page in there. And if the route says App 0, then I'm going to add an instance of App 0, then I'm going to add an instance of App 1. And I've got some locals and some props. So this is the key thing here, is this render component. So response has a render method in Express, which will render a view in your chosen view engine. But I just added a little bit of middleware that allows us to render a React component instead. And what you pass to it is a mixture of the locals that your Jade view needs. So there's a title there that it needs. There's also a component that it needs, so it knows client-side which component to mount. And then there's some props which are passed into your React component, and they get passed on server-side and client-side. And then the actual app itself, both of these look exactly the same. It's literally a single component that has a client-side router in it. So this is App 0, and has got client-side routes in for anything under App 0. Basically, it just lists links, so it creates some links. That list item component, it literally just creates a list item. Didn't mean to do that. A list item and with an anchor inside it. We'll come on to that in a second. So what does it look like? So it looks like this is really boring application, but that's not it. So if you go to App 0 page 1, it renders 4 links. Renders 4 links, 2 links in App 0 and 2 links in App 1. And the links in App 0 are client-side, so if I click this link or this link, it doesn't result in any round trips to the server, and it renders a different page in that client-side app. Obviously the backbone is working. But page 1 in App 1, page 2 in App 1, both round trip to the server. But now we're in App 1, so any further links in App 1 don't generate any round trips. But if I go back to App 0, I get another round trip. And if I'm on page 2 of App 0, if I refresh this, if I just click it, there's no round trip because I'm in App 0 already. But if I refresh this, the server renders the page in exactly the same state. So that's like 2 single-page applications working isomorphically, being rendered on the server or the client, and no different whatsoever. So the great thing about all of that is that you get it works without JavaScript enabled by default. It's just that when JavaScript is enabled, the only difference is that every link, everything is rendered by the server, regardless of whether you're in App 0 or App 1, because there's no difference. There's no client-side router that can take over the route for you, so it has to go back to the server, but the user doesn't know any difference. Which is quite amazing, actually, when you think about it. If working in non-JavaScript environments is important to you, I don't know if it is or not. No. So, yeah, earlier we were talking about the big message that you get when the server doesn't render the same thing as the client. So in this component here where we're actually rendering the links, we render red or blue depending on whether it's at 0 or at 1. But if we say render green regardless, then obviously they'll all be green. But if I don't recompile the client-side script and just restart the server-side script, so now the server wants to render all those links as green. The client has still got the same script that it had before, which is the same script that it had before, so it's going to want to render red and blue. So the server's going to do the first rendering, and the client is going to do the second rendering, and the client's going to win, obviously, because it gets to do it last. Or not.
Scripts disabled.
Oh, sorry, yeah. Yeah, well done. Right, so the client's going to win. The script disabled, obviously the server wins. And that's the big message you get. It says React attempts to reuse markup in a container but the checksum was invalid. This generally means that you're using server rendering and the markup generated on the server is not what the client's expecting. React injected new markup to compensate, which works for you. But you may have lost some of the benefits of server rendering, so figure out why it's different. So
This is a master.
I know.
It's amazing.
I know.
I know, no, but yeah, exactly. Because we have to write that like in add like 30% onto every project. It's just like, cool.
I know. It's great.
It's completely different what Angular did. I listened to one podcast and they decided they're never going to inject this kind of stuff. They're just going to refer to the error code that they're going to refer to some website. And you basically click on it and you have to find it. It's like error code 53. And then you find something.
Very Microsoft.
I like it.
Yeah, actually really, really helpful error messages. Obviously they take up loads of space in your client-side script. But
that's the unminified.
Yeah.
If you use the minified one, it's like 100k, then unminified's 500k.
it makes a massive difference.
Yeah, it's 500k.
A massive difference. So we're using Browserify. We can look at that in a second using Gulp. But we found actually one of our student interns who's just started with us full-time, Joe, who started playing with React a while ago. He discovered that this thing called MVFi, which sounds ridiculous, but it's a plugin for Browserify, which it gets a chance to replace all of the if node env equals production with if production equals production. So actually it replaces node env with whatever node env results in. That's all it does. But then when you pass that through Uglify 2, Uglify sees that as a redundant code block and removes it. So you actually end up with executables that are packed JavaScript stuff, which gzips down to like 30k or something, which is ridiculous. Anyway, but yeah, so we're still running old script here, so obviously the client's trying to do something different. But if we just recompile that, then better start it again. Then it works fine and the message goes away. But yeah, I mean, I just wanted to show that it's quite easy for you to generate exactly the same thing on the server and the client, and you get helpful warning messages when you don't do that. We didn't look at this little bit of middleware that actually does the rendering of the component. And I've probably gone a bit big. Oops, a bit big there. So that's all it is, and it actually doesn't need this clone operator in here either. So all it does is it just sits in the middleware paths for the routes that you want to use it, and it just adds this render component render component method, which just calls React's render component to string, passing in locals.props on the component you specified, and then puts that back on the locals again. So when you render the layout with those locals, the content's available to the client. And then, so look at the Jade again. So that content.
So is that why you're still using Jade, even though you're not using any elements of Jade, just so you would be able to call res.render component? Because it wouldn't let you do that if you didn't have a rendering engine.
Well, so it would, because I'm adding render components, so I can do what I like. It's the res.render bit which I'm passing the locals to, but I needed because I tried. So when I first tried it, I tried to have React do that top bit as well, you know, the layout bit as well. But I don't know if you know how it works, but it's quite simple. Is that when the server renders it, it puts a checksum at the top on the root element, which the client when the client re-renders, it looks at that checksum, and if the checksum has changed, it knows obviously to give us that big error warning message, but also to do something different. So or to rework the UI. So that checksum is in the wrong place when you have React render that, because if React renders the layout as well, then the checksum goes on the top HTML element. It's going to be up here, but when I was getting the server and the client to do the whole lot, and to replace the whole document element with a new thing, didn't like it. I couldn't work out whether it was because I had this. I was replacing the script that I was running and all sorts of things. You know, the script tags were being replaced with new script tags, so they were being reloaded, and I don't know whether. So in the end, I thought, well, replacing the whole document is probably a little bit ambitious, and we should just replace something inside. But then I couldn't get React to do the outside bit because the checksum would go right at the top rather than there. So because you kind of have to do exactly the same thing on the client and the server. Anyway, I think that's the only interesting things in there. This is the gulp file, which uses browserify. So it uses liveify to compile the live script, and then if it's a production environment, envify and uglyfyify, which we talked about earlier, but that packs it up really tight, which is great. And then we just pipe that through vinyl source stream to get it back into something that Gulp can use, and then write that out. And Browserify is brilliant because it's actually really important for isomorphic apps, because you want to be able to just use node modules and require them. You want the same environment on the client as you've got on the server, and closest you can get to that. So being able to just require stuff, which is brilliant. I think that's it. So anyway, it's a public repo. I'll put the link up. I haven't actually put it up, but it's. I'll find it for you and I'll stick it on the Meetup notes. And it's public repo, so anyone can contribute or to the broadcast and see if we can work out what a really nice pattern for doing isomorphic apps is, because I think in my head it's the least intrusive one that wins, and everything I've seen so far has been really takes over everything. So anyway, I think it really relies on just that one render component to string, and if we've got the same. Oh, there's one thing I missed actually, quickly, is that when the client renders the app, it needs to have exactly the same props available to it as as the server. And when we were trying to work out how to do this, we wanted, in the past, we've sort of serialized our object graph into JSON and put it in inline script. But if you've got a content security policy, it doesn't allow that. And a lot of production apps have that, where you don't have any unsafe inline script. And that becomes a little bit difficult. I mean, you could still load it in, I suppose. But we discovered that you can put it in data attributes on, say, something like the document element. And there's actually no limit to how much data you can whack in there. I know it sounds ridiculous, right? But we've got like stacks of data that serialized JSON in.
Exactly what React Rails does as well.
Is it?
So Gender.
Is it?
Rails with React.
Does it?
Yeah,
Does it do the same
does
thing?
that on the other that components.
Yeah.
But yeah, provides.
I mean, we've got things like data config, data translations, data props, data helpers to allow to give you the same functionality client side, and you've got server side, all sorts of things that are serialized into data attributes on. And it's a bit ridiculous when you look at your page and you've got sort of like your opening HTML element is this big, but on mobile devices we haven't had a single problem anyway. Nothing. Sorry? No, absolutely fine.
Is it actually any more secure, or is it just keeping options?
I think it is more secure.
Did you try a script of a different type? Because that, so presumably the content security policy should only apply to scripts that are executable. So if you're putting it in line with in a script of like var my data equals JSON string like this, then I would expect the content security policy to block that.
To block it.
Could be it.
Which we kind of need to do in a way.
Yeah.
If you wanted to get deserialize you.
But you could do the same. You could take the same approach.
JSON
You can have a script with a type attribute that specifies it as like application/JSON or whatever.
Right.
You make something up, and anything that's not JavaScript means that script block gets ignored.
Right.
Parsing it.
Yeah.
And then you can later go in and say, get this script block and tell me what the content of it is, and then parse it in just the same way as you would with the data attribute.
But then you need
That's
to
actually
around whether it's text content in a HTML or HTML or to actually get out of the script.
I'd say this approach is probably nicer, but how it works.
How the JSX parser that Facebook give out works. You put it, if you put stuff in line, you put text JSX. Checks template or something, and then it just goes on body ready and just goes and browser passes the JSX to JSON.
Yeah, we played with a few different things, but as soon as the content security policy didn't allow us to run any inline script, I think that would work probably with JSON, different type. But this has worked brilliantly well. We've not had a single problem with it, even with like massive amount of stuff. The only downside to it is that it looks great there, but those quotes and angle brackets have been escaped, so it's a little bit bigger than it would normally be.
You have new lines in there.
But if you use it, if you actually want to use it, then yeah, I think you can. I don't even put any caps in it. I don't know. I mean, it would be escape, wouldn't it? So.
What about SEO? Is it not going to treat it as some, malformed HTML page?
Well, I think data attributes are reserved. Everyone, it's an accepted usage of data attributes. I think it's quite good. It's really handy. So in the Jade view, right at the top of the Jade, we effectively just stringify the props in there like that. So it just makes it really, really easy to get. And then on the client, we basically just just here, look, props. It just parses. If we've got data props with some JSON in it, then that's the props that we're going to pass into the component, and we fetch the component from here, depending on which application we want to mount. and that's based on the class name of the layout. Just here, class equals component, which is injected. Where is it? No. So if we've got a mount point, try and get a component. If we've got a component, instantiate it, and then ask React to render it to that mount point. And so we can mount as many apps as well. The reason why we have to do this is because when Browserify compiles this, it does a static analysis of all of your script and looks for require statements. And so if there isn't an explicit require, then it won't require it. So in order to get Browserify to put app0.ls into your output, you have to have some kind of physical require. You can't build this. You can't build this up dynamically. It's a bit awkward, but yes, I mean you have to client side. You have to tell it which to mount. But so that's it. I'll put the links up if anyone's interested in contributing or anything like that. Cool. Bobbs. Do you want to plug yours?
Yeah, that's what easiest. Have you got HDMI to back up?
Yes.
All the other ones.
No, I think we do somewhere.
If you don't, this is online, so I can. I've got DVI or VGA. Okay. Quick show of hands. Who's used Jade at all? Okay. So about half. I'm going to quickly run through kind of what Jade is as quickly as I can, and then get on to the interesting stuff. So a brief Jade introduction. It produces HTML and supports dynamic code. That's kind of its key thing. It also supports some kind of reusability and some things that are ready for reducing the amount of kind of boilerplate code you write. So here's a basic HTML page. We've all seen these before. It's got tags. It's got some attributes, a doc type, etc. But the closing tags feel kind of silly and useless given that we've got indentation anyway. So Jade drops those, and the start of virtually every line is a tag, so we drop the angle brackets as well. And we end up with something a bit like this. We put a dot after the P just to indicate that the indented block inside it is plain text. And we put brackets around the attributes to group those as well. But other than that, this looks a lot like the original HTML, but with the closing tags removed and those angle brackets gone. So I said Jade supports dynamic output. That top block of these three is Jade, and the first line says output this JavaScript variable, and the next line says output this JavaScript variable, but don't escape it. So then if you use the JavaScript code in the middle, you could compile that template and then call that template with some locals, some values, and it would render the output, and we get the escaped output on the top and the unescaped output on the bottom. The way that kind of works is that Jade template that we saw at the top gets compiled into this JavaScript code, or something kind of like this. So it creates a buffer variable to store an array, which is an array of the strings that will be in the output, and then it pushes the various values into that array, and at the end it joins them and returns that. The values it's pushing in there are the HTML code.
So this obviously isn't using React at this point. This is just rendering conventional, traditional Jade to a string. We can do attributes dynamically in the same way. In Jade, any of the attributes are just normal JavaScript values, so they work just like regular JavaScript values. We have syntax for conditionals, so if, then, if, else if, etc. We have loops, so each, for each, etc. And finally, we support custom JavaScript. So that's a dash at the start of the line. We just treat that line as JavaScript, and it goes straight into the compiled function at the end that gets generated. We support includes, so you can break your template up into multiple files. And we support a whole host of other features, most of which aren't hugely relevant if you're building with React. So onto React Jade. So React Jade is a Node.js module. Quick show of hands, who uses Node.js? Has used Node.js? Cool. Okay. So running Node on the server, running JavaScript on the server side using Node. You can install React Jade from npm using that command at the top, and then require just loads the module in from using Node's module system. And React Jade provides a method for compiling a Jade template to something that returns a React component. So we can use jade.compile file with the view.jade file name, and then we can call that function and we'll get back a React component. And say we were on the server side, we could then use react.render component to string and get the HTML string out of that, which feels like kind of back where we were 10 minutes ago with Jade. So given the Jade template at the bottom there, with the heading and the article and paragraph, we get HTML output that looks like this. So not quite what we had with the original Jade. So this is just giving us the HTML with all of React's extra attributes in. So that's the React IDs and that checksum that was talked about earlier. And it's put some extra spans and some divs in. And some of those, I think, could be removed. React doesn't let you return, doesn't do anything useful if you return an array of components from a function. So that's why it gets wrapped, why by default React Jade just wraps everything in one outer div. Yeah, that's that. So in order to run client side, you need a way to, you want to be able to compile your Jade template in advance and then give it to the client as a compiled bit of JavaScript. So React Jade also offers a method called compile file client, which takes a file, compiles it to JavaScript, and then returns that string. So this is a self-calling function that returns a function. So this whole expression will evaluate to the render function, which means that you can use it inside some other file. So if you put like var view equals at the start of this snippet and a semicolon at the end, you get something more useful. But the goal was kind of implement the lowest level thing and then let users figure out how they want to use this in their own applications. So the code here, I'll quickly run through this, what it's doing. The first thing it's doing, so it's detected that article text variable at the bottom there as being a possible input to this function. So the first thing it's doing is saying, well, we don't know whether that's an input to the view or a global variable that you're referencing. So let's get a reference to that global variable if it exists. So it's doing type, that's the type of article text equals undefined, is checking whether it exists, and then it gets undefined if it doesn't exist, or the actual value of article text if it does exist. And then inside the function, it does essentially the same check in reverse on the locals. So it says, is the article text actually part of locals? If so, use that. So if article text was passed in, use the local one that's passed in. Otherwise, look for a global one, and failing that, just get undefined. Then we do the actual really interesting bit of rendering the React DOM. So this is saying, so this is the actual React code that gets generated by this. So it creates a new React div and inside that it has an array with an H1 and an article and a paragraph, as we would expect. And then at the bottom, it's just passing in React, and it will look for a global React, and if that fails, it will fall back to using require, so it will assume it's in a Browserify-esque environment and require React that way. It also has first-class support for Browserify. So what I'm doing here is I'm using Browserify middleware, but you can use any Browserify compiler that you want. You just specify a transform of React Jade, and then that's it done with the Browserify stuff. And then in your client script, you require React, just as you normally would. You require React Jade, and then you use React Jade as if you're running on the server, as if you've got all of the files you have on the server. So you call jade.compileFile again, like we did earlier, like we did on the server side. Give it that file name, and then use the function that comes back. We can then use react.renderComponent with the function to render that component and stick it in a placeholder div. So now that so this obviously won't run on the client as it stands, because it's got to do a file system operation. It's got to read that view.jade file. And even if it did run on the client, it would be quite slow because it's got to do the whole compilation of the Jade file into React, and that's painful. It involves doing all sorts of AST manipulation, and Uglify.js gets in there, so you don't really want to download all of that and run it on the client. But what happens, because we specified that Browserify transform, the magic of that Browserify transform removes all of the need to worry about that from us. So what's happening here is internally it's using React Jade's compile file client method to get the JavaScript to run on the client, and then it's replacing the jade.compileFile call with the result of that, and it's also removed the call to require React Jade because we no longer need it because we're not using it. So this will then run on the client and work just as we expected. And coming back to that theme of isomorphic applications, this is very similar to what we saw earlier running on the server side. So I'm really keen to look into where we can make these exactly the same and figure out how React Jade can fit into that kind of context. So how it works. I maintain Jade, so I kind of have a decent understanding of how that's all put together and how that all works. But the basic idea, I didn't want to rewrite a load of that stuff. I wanted to reuse all of the Jade machinery. Unfortunately, Jade is set up to make that relatively easy to do. So I reused the lexer and parser of Jade. So that's the bit that takes the Jade string, splits it up into individual tokens. It says this is a tag, and this is an open brackets, and this is an attribute key, and an equals, and so on. Splits those things up. And then also the parser, which takes that stream of tokens and builds a kind of tree model of the world. And that gives us something called an abstract syntax tree. So that's actually the bulk of the work of Jade done. So all we now have to do is take that abstract syntax tree and turn it into JavaScript, but this time turn it into JavaScript that generates React components rather than JavaScript that generates HTML. So this is part of that compiler. I haven't copied the whole thing, and this is slightly simplified. But the basic idea of what it does is it assumes it has this tags array that it maintains throughout. And if you look at the visit tag function, so this is saying if I'm looking at an AST node that represents a tag, this is the function I use to generate the JavaScript for that. And the JavaScript it generates pushes the React element into the tags array. And for any children it has, it builds that up by adding a self-calling function that declares an inner tags array and then returns tags at the end. And this is kind of inefficient and a quite poor way of doing it for most cases, but it's pretty much the only way you can ensure total support for the whole of Jade, so you allow people to put custom JavaScript wherever they like and whatever custom JavaScript they like wherever they like to in their Jade. So doing it this way makes it relatively easy to have those properties, but it produces relatively inefficient code. But the code we saw earlier wasn't that inefficient, and the reason for that is that we do an extra intermediate step. So we also have a customized compressor. So this is using Uglify.js to compress the resulting JavaScript, which it does by two optimizations that are not generally that useful for the rest of JavaScript, although they are generally applicable. So you could apply this to any JavaScript code, and it might make it a tiny bit smaller. I've thought about submitting pull requests to Uglify.js itself. But the first one of these is just saying, if there's a self-calling function that contains nothing but a return statement and doesn't take any arguments, then you can just replace that with the return statement itself. With the value that would be returned by it. And then the second thing we do is we call this collapse to return statement on any functions. And what that does is it looks for a very specific type of function, which is a function that starts with the declaration of an array and ends with returning that same array. So it starts by declaring a variable that is an array. So that's this is array variable declaration for the first node. I'm missing a close brackets there, but sorry. So we start by checking that. If the first thing is that's in there is the declaration of an array, and the last thing that's in there is the return of that array, which is this is return statement name. And if every other statement in this list is a statement that says array.push some values, then we know that we can replace that with just a constant array. We can just define the array instead. So if it doesn't match those properties, we return, we don't change anything. If it does, we rebuild this array, and then we replace the entire body with just a single return statement that says return this array. And the combination of this one happening first to a function and this one happening second means that we end up with something that, rather than ending up with this horrible, so it means that if we take that self-calling function that starts by declaring a tags array and ends by returning it, then for the common case, we get to replace that with just the array, which simplifies everything down quite nicely. So there's a few things still to implement. If you've come across Jade lots, then mixins are missing, attribute extension and merging, this ampersand attribute syntax is also missing. Case and when still need to be implemented. There's a few other niggling things like interpolation, just I haven't done that yet. Some of these are quite challenging. Some of them are fairly simple that I just haven't got around to yet. Outputting unescaped HTML results and stuff, that's actually, like, React tries to make it really hard for you to output unescaped HTML, which is a good thing, but it conflicts with the semantics of Jade slightly. So we end up with a wrapper div if you ever need to do that, but that's fine. That doesn't seem like a big deal. So yeah, that's all, folks. Is there time for questions?
Yeah.
Does anyone? Yeah.
So what led you to do this?
So I hate JSX as a thing. I just I couldn't read it. It made the documentation really intractable for me. So I ended up looking at the JavaScript, the compiled JavaScript in the docs, and then I was like, okay, this React thing looks kind of cool. I can grasp it. Built my little demo app as you do, the kind of hello world of React, and got quite fed up with the React.dom and went, okay, that's why they created JSX. But I still hated JSX too much to start using it, so I kind of went, well, I know Jade really well, and it feels like an actual fit. And there's been quite a lot of chatter on the Jade issue tracker from people going like, could we create a Jade compiler that automatically generates like knockout bindings or angular bindings or whatever other like insert binding language here. And most of them are really ill-suited, partly because they're all doing this two-way binding, and partly because they're doing, like, if you look at something like knockout, you have like an observable that you have to unwrap, and do you magically unwrap them in Jade, or is that too much magic? And that gets really complicated. Whereas React, because it's got this really simple one-way binding system, or not even binding, this like one-way rendering pipeline, that actually works the same as Jade. And I have used Jade before in client-side applications where, where you've got like a table of data and a search box, and you live update the table as people type. And I've used that with just Jade and re-render the HTML and stick it back in there. And that, it's a bit flickery, but it's fine. So this is just like that, but a bit better.
So just so your goal would kind of would it look like having, say, your standard React component, you call the render function, then the return, you'd actually just, after that return, just literally return a big block of Jade, and then potentially your compiler would go through and
I think
so it's returning valid JSX.
I think so. This doesn't use JSX. This never touches
JSX.
JSX. But yeah, I see what you mean. Yeah, I think my kind of imagining of it is that you keep your template in a separate file to your JavaScript still. That way you have pure Jade and you have pure JavaScript, so you get all of the nice tooling support, and you're not kind of magicking up your own languages from thin air. But then you get to just write inside your like view model, you can just have this jade.compile file instead of the render. So in your React component, if you use something like Browserify to compile it, then you can just put jade.compile file instead of the bit where you specify the render function. Cool. Thanks, everyone. Love to talk about isomorphic applications.
I guess there's no real difference between a React component and an HTML component in the sense that React. You can think of them interchangeably.
Well, they have the kind of AST representation of them is the same. There's no need for that to be any different, which is why it was like we're generating an AST that looks like quite similar to the React model.
Very good. Great. Okay. So thank you very much, everybody. That's really good. So we're going to do another one on the 23rd of July, which is also Wednesday. So we'll put that on Meetup tomorrow. And I think we might take a month's break for summer. I don't know what everybody thinks, but I think everyone's going to be away on holidays, and so maybe take a month's break and then start again in September.
I think there's a closure meeting for Palm.
Oh, is that on the same day again?
Yeah, it should be on the 1st of July.
Yeah, you're also clashing with Elnock for London Node, which is probably.
Okay.
It's just Wednesday.
So is it better to put it on the 30th
Just to
then?
make the announcement, I think it's next, the first. I think if you look at meetup.com, you
Yeah.
can see when it is.
Okay.
The fourth, what did you say that was?
What's it? Elnock, London Node User Group.
That's on the 23rd, is it?
It's the last Wednesday of every
Wednesday
month.
The last Wednesday is the 30th.
Okay, it might not be the 23rd,
Okay.
next time.
All right. Okay.
So the last or it's either the last or the fourth. I can't remember whether it's counted from the beginning.
Because I know we clashed with a Hasselhoff group as well that was doing interactive web apps today. So I don't know. It's quite difficult to get a date, but is that Should we change it from the 23rd, do you think, or not? Yeah?
Well, I mean, Tuesday's quite a busy day, Wednesday's quite a busy day,
Yeah.
Thursday's quite a busy day.
Yeah. It's not really a good one, is
Not
it?
as fun. Yeah. I think we're going Monday.
Oh, wait.
I know.
Anyway, so yeah, so please, this is everybody's youth group, right? So let's all do talks and get involved. And I don't know how long we can stay here for, because there's already 130 members, and I can see us getting too big for this space quite soon. So had a few offers of other places already, but I mean we can stay here for as long as we can. We've got space for as well, but that's even more positive than this. So I think anyway, we'll see how it goes. So yeah, have some more beer, some more pizza. It's really cool now. Have a good chat, and thank you very much.